Hey, and welcome to the lesson on graphing radical functions. So what do radical functions look like graphically? So by the end of the lesson, you should be able to graph radical functions. And we're going to talk about what they look like and why that makes sense. First, we'll take this square root equation and we'll talk about actually just graphing it. So it's going to be pretty similar to graphing any other equation. You want to make a chart and find x, some points, some x values, and then their corresponding y values that you can plot on a graph. The thing to take into consideration for square root equations or any radical equations with even indexes is that you cannot have a negative under the radical. So therefore, you need to take what's inside the radical, in this case 3 minus x, and you have to set that greater than or equal to 0 because it cannot be negative. And you want to find the value of x for which that would be negative. So for example, in this problem, you see that x, if we do that, 3 minus x is greater than or equal to 0, and we solve for x, see that x is less than or equal to 3. That means that for any value of x that is less than or equal to 3, then the graph will have a real solution. If the number is any greater than 3, then we'd have a negative under the radical. For example, 5. 3 minus 5 would be negative 2. There are no real solutions to the square root of negative 2. Therefore, it will not show up on a graph of all real numbers. So that's something you want to take into consideration. And then you want to plot your points. If I do that here, we have the points plotted up on the right, and then the curve under that. So I plot my points and I do that curve. Now it's important to know the parent function, or the basic idea of the curve. And then now we're going to talk about what a radical function looks like. So if I go to this slide, this is the graph of, y equals x to the 1/2, or also known as the square root of x. Now, this happens to be the inverse function of y equals x squared. For example, if I square root both sides, square root of y equals x, switch them, so the square root of x equals y, therefore these two are inverses, which basically means that if I graph y equals x here, see, I graph y equals x there, and I would graph x squared here. Sorry, that's a poor drawing of the graph, but you get the idea. Now if I would flip it, here I would get the square root of x. Now you might be asking, well, why doesn't it look like a parabola? Well, here, this bottom part is not there. That is the imaginary part of the graph, because you cannot have a negative square root. So our parent function just looks like that. That is y equals the square root of x. Now in our problem, y equals square root of 3 minus x, we have, if we put that in the form of, so y equals the square root 3 minus x, or y equals the square root of negative x plus 3, or y equals the square root of negative x plus 3. So there you go. So because of this negative, it's going to be reflected across the y-axis, and because it's, sorry, this should be minus 3. Caught myself there. And because it's minus 3, remember our transformations, you would think that it would go to the left 3, but it actually goes to the right 3. So here is our our point of origin for the graph. Instead of the y-intercept being here, goes to the right 3, and therefore we have our graph that is something like that. Actually, here's a better idea of that. Also, if you make if you set x equal to 0, and you substitute that in the equation, your y-intercept would then be y equals the square root of 3. Square root of 3 is 1.87 something, and that is actually the y-intercept right there. And just for your knowledge, this is a basic cube root function. Cube root function. Now remember that the cube function looks something like this. Something like that. And therefore the cube root function, which is the inverse, remember cube and cube roots, they're inverses of each other, inverse operations, so the functions are inverses as well, and they would reflect over the line y equals x. So that's what radical functions look like graphically. So I hope you learned a lot. Make sure you go do your assignment. If you have any questions, reach out to me. Love to help you. See you in live class. And if you need me, I'll be in Math Cafe Monday, Tuesday, and Wednesday at 11. And if that doesn't work for you, then there's always a teacher in there, 9 to 3 every day. And if not, reach out to me and we can plan something accordingly if you still need help.